Good afternoon. Welcome to course Thermodynamics of Materials. Today we are into lecture 113 and 140. So we will continue with solution thermodynamics. Specifically we will actually work with assignment number 9. These problems are based on solution thermodynamics. Yesterday, last day, we have already solved two problems. Okay, problem 1 and problem 2 solved. So we'll take up problem 3 today. Problem 3. So we may actually remove this. This is problem 2 already over. Problem 3. This problem 3 will be an interesting problem. This problem is okay. So we'll pick up problem 3. A. Calculate the activity of calculate the heat effect. Calculate the heat effect here. Heat effect delta H for dissolving 1 gram mole of solid nickel in 9 gram mole of copper, liquid copper, at 1200 degrees Celsius and 1 atmosphere pressure. Assuming an ideal solution is found. Okay. B. Calculate the delta S inverse for the process in A. Assume Cp of nickel solid is equal to Cp of nickel liquid. Nickel liquid, and data given is data delta H M for melting, M for melting, in the melting of nickel, temperature 18 or sorry 1728 K is how much? It is given 17,150 joule per mole. And melting point of nickel is 1728 Kelvin. Reference darken and garlic. Darken and garlic. Page 512. Solution this side. Solution here. You consider this 1 mole nickel solid goes to 1 mole nickel liquid. Temperature is 1473 Kelvin. Call it equation 1. 1200 degree centigrade means Celsius is 1473 Kelvin. And 1 mole nickel liquid plus 9 mole copper liquid goes to 10 mole of nickel, or rather copper nickel solution. Call this equation 2. Liquid solution. Okay, you may write liquid solution better. Liquid solution. Liquid solution. So what we have? Okay, equation 2. This is equation 2. This is equation 2. Overall, what we have? This 1 mole liquid. Oh, I'm sorry. This also mentioned 1473 Kelvin. Okay, mentioned. Okay. So clear? 1 mole nickel solid, 1 mole nickel solid goes to 1 mole nickel liquid at the temperature of 1473 Kelvin. That is equation 1, and then 1 mole 1 mole nickel liquid plus 9 mole copper liquid goes to 10 mole copper liquid solution at the temperature of 1473 Kelvin. So overall is, if you cancel this, you have the desired problem. Problem is 1 gram solid nickel. So your nickel solid plus 9 mole copper liquid goes to it is better right here 10 mole copper nickel liquid solution. Okay. Liquid solution. Okay, this is the overall. Okay. What is the temperature? 1473 Kelvin. So we have to get this. Okay. So to find delta H overall, find the delta H heat effect. Heat effect is delta H enthalpy change under constant pressure. This problem is under constant pressure, so no problem to find delta H overall. So delta H 1 1473 Kelvin, delta H 1 1473 Kelvin plus is what? How much? First you calculate this delta H1 is if I write delta H1 1728 Kelvin, will you buy this? These two same equal, because this value we know, data giving. This is actually melting of nickel. So nickel goes to liquid, solid to liquid. So at this temperature, data is directly given. But this is required. These two are same under what condition? Kirchhoff's equation. That is when enthalpy change is independent of temperature under the condition of delta Cp is 0. And this is here it is given delta Cp. So these are same. I like this. And what is this value? Complete this 17,150 joule. This is the enthalpy change of enthalpy of melting. This is the melting. Solid to liquid is melting. Enthalpy of melting of nickel at 1728 Kelvin is 17,150 joule, which I have written here. Okay, good. That's fine. 750 joule. Why this is true? Why? Since this is the reason. Cp nickel solid is close to Cp nickel. That is delta Cp. That is delta Cp is 0. And recall Kirchhoff's equation can apply to any chemical reaction or phase transformation equally. Can recall what is that? Delta Ht2 is delta Ht1 plus delta Cp dt T1 to T2. Apply this and you will get this. So this part is over. Next, second step, delta H2 delta Ht2 na? T2. This is T1. Second step, delta H2. What is the value? Delta H2. This is 1 mole nickel liquid plus 9 mole copper liquid producing 10 moles of copper nickel liquid solution, and the solution is behaving as where it is given ideal solution. If this, then what is the enthalpy change for this mixing process? This is mixing. For the mixing process in an ideal solution, what is this? Is nothing but 0. Because for ideal solution, enthalpy of mixing is 0. For ideal solution, which the given solution is ideal solution, enthalpy of mixing is 0. Recall this, enthalpy of mixing is 0. So this is, remember this. So this is 0. This is a mixing process. So delta H is, means delta H overall is what? Delta H is delta H1 plus delta H2. 2 is what? 17,150 plus 0 is 17,150 joule. Answer. Second, B. A is over B. What is the B? What you have to find? Delta S inverse. For this purpose, you have to find delta S system and delta S surrounding and combine them. Delta S system incidentally is actually, this is a system, is a actually mixing process. So we'll try to get delta S1 and delta S2 for the system, and then delta S surrounding separately, and then add them together and get the value. So let us take delta S1 to find delta S inverse. Okay. Overall means the combination of 1 and 2. Okay. So this delta S1, step by step, 1, 1, 1 and 2. So delta S1 and delta S2. Add them, that will be delta S system. Good. Go ahead. Delta S1 is what? 1 is how we write this 1. Delta S1 is what? 1473 is can I write this again like this line? Can I write similarly? Yes, we can write, because Kirchhoff equation, if we apply this can, you have a similar relation with respect to entropy. Similar, only it will be dt by t. Otherwise, same. Delta ST2 is delta ST1 plus delta Cp dt by t. In any case, delta Cp is showing and which is 0. So this will be, there is no difference between T2 and T1, which is 1473 Kelvin and 1728 Kelvin. So and what is this? This is okay. What is this? This will be what? You know what is delta system? Q reversible by T if we apply is delta H melting of nickel 1728 over the temperature itself What is this value? 17,150 divided by 1728 is how many it will be? 9.92. 9.92, this is okay. Okay, then you write here, these are under constant pressure. Q is delta H, I have written somewhere. Q is delta H, okay, delta H. This is actually under constant pressure, right? Shall I write here? Under constant pressure, Q is delta H. Note this. So 9.92. What's the unit? It was joule. So joule, what it will be? Joule per Kelvin. You can give per mole also. Since 1 mole is involved, you can give, but joule per Kelvin. Okay. Delta H 2. 1473 Kelvin. 2. What is the 2? You see, check the 2. This is the 2. What is the delta H? Previously it was 0. Enthalpy of mixing in ideal solution 0. What will happen? What is the entropy of mixing in ideal solution? Is it 0? No. What? Remember what it is? Minus R. Recall. Minus R XA ln XA. Like I am writing here. Minus R XA ln XA plus XB ln XB. Recall. This is the value. Delta SM ideal. This is ideal. Ideal. You can write this since it's ideal solution. So you may write somewhere. Okay. Since ideal solution. Now only thing, what difference? This is for what? How many moles? This is for how many moles? 1 mole. XA plus XB mole. But it is not 1 mole. It is, in this case, it is 10 moles. So we have to properly change it. It will be XA will be, this is Na, this will be Nb. This remains same. This remains same. Go by this. See, this is actually for 1 mole minus R ln XA, and for Na mole you multiply. Anyway, so I am writing this. Right? Na. So shall I give you the result? Okay, let us write this. Na ln XA plus Nb, or you can do this. So keep it this. You multiply by the total. It is for 1 mole. The total number of moles. N total. When XA is multiplied with N total, what is this? N total is, for N total XA, what is XA? Na by N total. Na by N total, and this is for 1 mole. For N moles, extensive property, so it will be Na. This will be replaced by Na. Okay, so Na total. So you have actually XA by this. XA is Na by NT. So it will be XA times N total is Na by N total times N total. Cancel Na shows that. Plus Nb ln Xb. What is this? Substitute minus R. Since ideal solution. Since ideal solution. So what it is? Minus, give this value, minus 8.314. Na means, A is actually, I should say, Na, A is what? Na, okay, you can consider anything. Say, Na say nickel, suppose nickel, So in nickel is how many? 1. Ln, what is the mole fraction of nickel? 1 by 10, 0.1. Plus Nb is 9, right? 1 ln plus 9 ln 0.9. You check this. Ln 0.1 unnecessary. Ln 0.1 by 0.1, 1 by 10, 0.1 mole fraction. This is 9 by 10. So 9 times ln 0.9, 1 times ln 0.1. How much it is? Coming as, it is actually, if you do this, 2.66 joule per Kelvin. So what is delta S system? What is delta S system? Is delta S1 plus delta S2? These two together constitute the system. Delta S system is how much it is? Tell me. 9.92. 9.92 plus 2.66 is how much it is? 12.58. It is. Oh, I made a mistake somewhere. This is not 2.66. Very sorry. You try this, you will get this. It is actually 26.6. I am very sorry. 26.6. Please check this. Because 8. Yeah. So you check this. This will be 26.6. So it will be 26.6 is how much it is? 36.52 joule per Kelvin over delta system. What is delta surrounding? Delta surrounding is what? Remember what I said? Delta surrounding minus Q process over T surrounding. T surrounding is what? What is the minus Q process? Process is under constant pressure is delta H by T surrounding. Okay, minus delta H process by T surrounding. T surrounding. What is this? Continue. What is the delta H process? And delta H process. Delta H process. First part. Delta heat effect delta H. How much it is? 17,150. So, and the T is under constant pressure. Q process is delta under constant pressure. Again, right, under constant pressure. This is already mentioned in one case. Okay, this is okay. Delta H process is how much? Right, still right, under constant pressure. Q is delta H. Q is delta H. Is what? What then? Okay, sorry. So what is this value? Put back the value here. What is 17,150? What is the T of the surrounding? 1200 degree centigrade. 1473 is minus 11.64 joule per Kelvin. So let me remove this. This problem is over. So delta is inverse. Hence delta is inverse. Hence you give a star mark here. Just remove this. Why shall I write? I am writing this side. This side. This problem is over. this side, no problem, star, delta S universe is what? Delta S system plus delta S surrounding. What is these values? System already 36.52, 36.52 minus 11.64 is what it is. It will be about 24.88 joule per Kelvin. What you will comment here is a positive value. Delta S universe is positive means it is a spontaneous process. Remember, delta S universe is positive means it is a spontaneous process. So, comment, this is a mixing process and we know mixing is a spontaneous process. This is demonstrated here. This has been, okay, this has been shown here in the result and this has been demonstrated. So, that is, so the result supports this statement that delta S universe is positive. So, note, comment, mixing is a spontaneous process. When delta S universe is negative, impossible. Delta S universe is 0 for reversible process or equilibrium, reversible or equilibrium. And delta S universe is positive for irreversible or spontaneous Thank you. This problem is over. So we will have to move to the next problem. Problem 4. So problem 4, let us, so this is already okay, and I remove this, all clear. Problem 4. The pH2 over pH2O ratio in an H2 H2O gas mixture in equilibrium with pure liquid lead and liquid lead silicate of XPBO is 0.7 is 5.66 times 10 power minus 4 at 900 degree centigrade. The corresponding value the corresponding value at 1100 degree centigrade is 1.2 times 10 power minus 3. Calculate the partial molar enthalpy or say heat of solution of liquid PbO in this lead silicate. Solution the pertinent equilibrium is lead is there, H2 is there, H2O is there, lead, H2, H2O, and lead silicate means lead oxide and silica alloy, a solution. So what is this? I will explain this. Lead liquid plus H2O gas, lead oxide liquid plus H2 gas. This is the pertinent equilibrium. You might ask me, okay, that is the delta G, let me write this, finish this. Delta G0 is 54,250 plus 24.3 T. This is given, data given. This data given. So now question is, you follow this. Note lead silicate, liquid lead silicate is a mixture of PbO and SiO2. A mixture or solution, right? Mixture or solution. This means PbO is in impure state. Just note this, okay? So PbO impure state will apply this in the equilibrium constant. But if we write PBO, then we will apply the impurity or the impure state of PBO in the equilibrium constant expression as follows. Okay. So delta G0 is the standard state. Standard state actually consider this standard, and that gives rise to equilibrium constant. So do this delta G0. So delta G0, the temperature is what temperature? 900 means 1173 is 82. 900 plus 273, 1173 is what? 82,754 joule. This gives you, this leads to, this leads to K. 73 is how much it is? 2 point, this gives or K 1173 is what? Exactly 2.06 times 10 power minus 4 using as you know delta G0 is minus RT ln K. So this what is K? You now write this. See how will apply lead silicate, lead oxide in lead silicate in this equilibrium. Let us see. So this is so remember in the present case, the present problem, one phase, at least one phase is impure state. You condense. One of the condensed phases is impure. This is condensed pure. Lead liquid is pure. But this is not pure. This is contaminated with silica. Like it forms a slag. Slag is a solution, mixture, and components are impure, not pure. So this has happened to this. But delta G0 refers to the standard. That is clear. From which you will get K and use the equilibrium condition, equilibrium constant expression. This is one. So one great difference between this and assignment number 7, where all condensed phases were pure, all. Since we are studying solution, so there should be impure phase, a component which must be in solution, in mixture, impure. Who is it here? If it were pure, both are pure, that would be a problem related to assignment 7 or those part of discussion. Since we are studying solution thermodynamics, we have to use the impure component, handle the impure component activities. So let me write. You follow this. See, I am writing. You will follow. PBO impure, but standard state is standard state. Standard state doesn't mean standard state is a standard. What is the standard state? If you ask me, this is pure liquid free energy, and this is the 1 atmosphere hydrogen moisture H2O, and this is pure PBO liquid, and this is 1 atmosphere hydrogen. These are standard states, and their free energy is delta G. This difference is delta G, experimentally found. But equilibrium constant will involve non-standard state or standard state, whichever applies. Let us see. I am writing activity of PBO. Right, PBO liquid, you can write, no problem. Times this is partial pressure, or gases you recall partial pressure, and similarly activity of PB liquid. Actually, you may always put in bracket that it is equilibrium state. Equilibrium constant refers to equilibrium state. Okay, quickly. These are all discussed. Okay, previously only one small change. These one of the activities are impure, and you will apply your concept of activity. Let us see. Let us see what is activity. So first of all, how you get this? This is, so these are equilibrated. These are equilibrated, and what is the equilibrium value at this is XPBO was given is this we use, and what is this? With pure liquid and lead oxide. So you apply this. So this is equilibrated system, and this is one. Under equilibrium, what it is? You write this. You write this out. Another line. Tell me what is activity of PBO liquid? Activity solution gamma PBO liquid X PBO liquid. As you know, activity is gamma times mole fraction. And this, and what else? pH2 by pH2 is given how much? What is the equilibrated state? pH2 by 5.66 times 10 to the minus 4. So I'm writing once more. pH2 by pH2O, pH2. So what is this? Gamma PBO liquid. What is X PBO liquid? What is that value? What is that value? This is the concentration of PBO in lead silicate. In the lead oxide silica mixture, contribution of lead oxide is 0.7 and the balance 0.3 is silica. So, but we are interested in lead oxide, PBO. So, 0.7. What is pH2 by pH2 is also given in the equilibrated state. What is given? 5.66 times 10 power minus 4. What you get? Or gamma PBO liquid. It is a good idea to mention the temperature, which is 1173, is coming out as, I have to actually take the result, coming as 0.52. 0.52. Okay, very good. Similarly, then it is repeated for another temperature, 1100 degree centigrade. 1100 degree means plus 273, 1373. 1373. So what we will do? You have to find K 1373. Similarly approach. Okay, and also here, okay, what is this? This value is 1.2 times 10 to the power minus 3 instead of 5.66 times 10 to the power minus 4. This is changed. Okay, you will see. Otherwise the data same. So start K 1373. Okay. So this is actually, if you calculate this 4 point, let me write the result. 4.64 times 10 to the power minus 4 is what? Nothing but K 1373. Do this way. From this delta G0. Delta G0 1373, then K 1373. You get this. Then what it is? Write this a full expression. Write similarly as previously. A oxide liquid times pH2 over activity of lead liquid times pH2O. This is one as before. It is what? Activity is what? Gamma PBO liquid, XH2O liquid. I am very sorry. XPBO liquid times what? pH2 by pH2 is given as what? Let us see. Value is 1.2 times. You better write in bracket 1.2 times 10 power minus 3. Or again you find out, or gamma PBO liquid, what temperature it is now? Temperature is 1373. If you calculate this, then you will get this value. 1373 is 1373 Kelvin. You may give Kelvin is how much it is coming as? 1373 Kelvin, 0.552. Acha, now you have to find the partial molar enthalpy, heat of solution, partial molar enthalpy of mixing actually. It is actually partial molar enthalpy of solution, or if you write a solution or mixing. Solution or mixing. Achha, by the way, this is reference is who? Reference Dr. Gaskell, Dr. Gaskell, second edition, page 580. Page 518. So anyway, so this is so partial. How you get this? Recall the relationship quickly. I help you recall. Actually, it is better we go up. I think this part of the solution we can remove. Recall this. What is this? Del effect of temperature on activity coefficient. Universal relation. And this will be related through partial molar enthalpy of mixing, which is asked. d gi bar m, recall this, by T by del T is minus, under constant pressure composition, I am not writing which are valid here, minus hi bar m by T square. This will give, if you recall this will give gi bar m is RT ln ai, TT cancel, R ln ai, ln ai then broken into ln gamma I plus ln xi under composition, xi is a constant, will be out, and you will get this relation ln, if we apply this ln gamma PBO, to go back to this relation and you will find this ln gamma PBO 1373 over ln gamma PBO 11, what is the other one? Is 11 AJ. I'm sorry, this 1173 is what? Is hi bar in integration dt by t square is minus 1 by t minus plus 1 by t is 1 by t2 means 1 by 1373 minus 1173. Recall is h by m by r, because there is RT, R is there, R will go down there, or from this side to the other side, denominator. Given this, I can remove this line also, or put the value in, what is this value? 1373.552. What is this value? 0.52. 0.52. What is R? 8.314. Everything is known. Or A, I means what? I am very sorry. I is what? I is PBO. PBO. Okay. This is about PBO. So I PBO or H PBO bar M is PBO bar M is minus 40,000. 4,000. Answer. Answer. So this is your partial molar enthalpy of mixing. That is given. Calculate partial molar enthalpy or heat under constant pressure enthalpy heat. Same. Partial molar enthalpy of solution is actually mixing. Mixing. That's why aim is there. Mixing. So this is the answer. This problem is also over. Very good. And still couple of problems remaining. Problem 5 we'll take up now. So go fast. Remove this. Problem 5. Problem 5 says this is actually problem 5 is the activity coefficient the activity coefficient of zinc in liquid cadmium zinc alloys at 435 degrees centigrade Celsius can be represented by what? Log gamma Zn is 0.38 x cadmium square minus 0.13 x cadmium cubed. This is given. Calculate the corresponding expression for the composition dependence of log gamma Cd, and hence calculate activity of cadmium in the XCD is 0.5 alloy at 435 degrees centigrade. So this is the problem. Again, reference D.R. Gaskell, second edition, page 377. So we'll take up the solution. This side, remove this. Solution. Log gamma Zn is 0 given. 0.38 x CD square minus 0.13 x CD cube. Apply Gibbs-Duhem equation. Pertinent Gibbs-Duhem is what? To get the you have to find log gamma. This log gamma CD as a function of here in terms of the other G xg. Similar, but this coefficients will change. These numbers will change. Here too. This is the question. So what will apply? Gibbs-Duhem equation. So this is Gibbs-Duhem equation is what pertinent? Gibbs-Duhem equation. This is the question. This is the question. I said Gibbs-Duhem equation. Which one you apply? Since it is gamma in terms of gamma. So x zn xa equal xa d ln gamma. Ln it is log. No problem. Log and ln are separated by which factor? Ln x and log x is separated by 2.303 log x. So it does not matter. The coefficients will change. These numbers will change. These figures will change. Okay, only. So if we make it ln, but in x z n log gamma n. So write this activity. What is it? D log gamma zn. Tell me plus x cadmium log gamma cadmium is 0. This is Gibbs-Duhem equation. Or try again. Or x zn. What is the d log? Is okay. Or will you do this? Well. What is this d log? Find this. D log of this d is what? D 2.76. This is very easy. 2x CD dx CD. Check this. D of this 2x CD minus this is 3x square. X cube 3x square minus 0.39 x CD square dx CD is what? Is nothing but the plus I shall continue plus x CD log gamma CD is 0. Okay, very good. Or log gamma CD is what? Okay. Or sorry. I am sorry. You have noted this is d log d log gamma CD is 0. So plus x CD d log gamma CD is 0. Take this left hand side or x CD well x CD d log gamma CD. You know x CD d log gamma CD is actually what it happens, it becomes minus x zn 0.76 x CD dx CD minus 0.39 x CD square dx CD. As you see, x CD is very good. Minus x zn 0.76 x CD dx CD minus 0.3 x square. Okay, very good. Now you see x CD cancel. This xcd square cancel xcd. This here we can write once more is minus xzn, okay, xzn, write nicely 0.76 dxcd minus 0.39 xcd, only xcd dxcd. Happy? Now our integrate between limits, you have to get log gamma c. Integrate between what value? Xcd is xcd, and the lower would be one which is convenient for you, for which you know the gamma, that is xcd is 1 when gamma cd is 1. So this is, so you apply this also here this side. And another thing you follow, will you follow this? I want to express in terms of zinc, this side zinc, it should be all zinc, like this is all xcd, this should be all zinc. So convert, first of all absorb this minus into this, minus absorb this xzn, follow with me, 0.7 minus dxcd is nothing but dx zinc, binary system. So this is dx zinc, and minus dxcd is, okay, minus, this is this is dx zinc, and this will be plus then, okay, what is, I'm very sorry, minus absorb, this is minus of dx zinc, okay, minus 0.39 xcd, I'm very sorry, this minus dxcd is dx zinc, note xcd plus x zinc is 1, binary system. So dxcd is minus dx zinc. We know this. 100 times we have done this. You know. So now we are still, it is not complete because CDs are showing here. We express in terms of zinc, all zinc. xzn, dx zinc I take outside, 0.76 minus 0.39. What is xcd is 1 minus x zinc, obviously that you will do zinc, and this you do this, give a second bracket and dxzn. And what is the integration limit? Here also same, xcd is 1, xcd is xcd, just copy same, but here you actually start, since it is dxzn, you give the in terms of zn. So xcd is 1 means then corresponding xzn is 0, and xcd is xcd is x zinc is x zinc, x zinc is x zinc, okay. So this, so what you get out of this, continue, xzn is 0 to xzn is xzn, as if xzn, and give this integration sign, and what you have, you just tell me minus 0.39 and 0.76, 0.7 xzn, so write this 0.37 minus 0.3 xzn, you know, minus 0.7, clear, plus 0.39 xzn, but there is a xzn outside, so it will be, I repeat, I am very sorry, it's only 0.37 plus 0.39 xzn, but there is a xzn, so give xzn here, a square there, and then you have the integration dxzn. Now do the integration. Tell me what it is. 0.37 by 2 xzn square, first term, plus this is 0.39 by 3 xzn cube, integration. This is upper limit, and lower limit of xzn is 0 means 0. So this is the answer. So this is 0.185 xzn square plus 1 3 x Zn cubed. Yes, 1/3 x Zn cubed. Happy? One of the so this is now left hand side I have not done. Okay, this you do here. Okay, this is what integration of this log gamma cd for the limit is what xcd is 1, xcd is xcd, xcd is xcd. What is this? Or you write finally when log gamma cd minus log gamma cd log 1 is 0, is that value is 0.185 0.185 x Zn square. Wait a bit, wait a bit, wait a bit, wait a bit. Star, give a star here. Give a star here, here, or maybe here. Remove this star here. Or log gamma cd minus log 1. When xcd is 1, activity is 1, gamma is 1. Log 1 is what? 0.185 x Zn square plus 1/3 plus 0.13 x Zn cube. Still another line, just final. This is minus log 1 is 0. So log gamma cd is 0.185 x Zn squared plus 0.13 x Zn cube. Answer. Okay, this answer. This answer. Okay, happy. So this was given. This you have derived, arrived at this. Okay. So the gamma cd is a function of x Zn. Gamma Zn is a function of x. Okay, clear? This is the procedure. But there is another part. Calculate. This is okay. And hence, calculate activity of cadmium in the xcd is 0.5 value at 435 degree centigrade, means actually the temperature is 435. So to do this, so remove this. This is not required. Last part, to find activity of cadmium when xcd is 0.5. xcd is 0.5 and the other is zinc is also 0.5. Anyway, this is important. What is required? Gamma. You know, activity cd is gamma cd xcd. How will you get gamma? xcd is known, gamma I. So find gamma cd. How will you find this gamma cd? Use this log gamma cd is what? 0.185 x zinc square. X zinc means xcd point zinc means implies x zinc is 0.5 also. Is 0.5. X zinc means 0.5 square plus 0.13 x Zn cubed. It means 0.5 cubed. Is how much it is? Let me check. This is how much it is coming as. Okay. This is 0.046. 0.046. 1/4, it is 1/4 is correct. It's correct. Plus what this is coming as 0.046 plus 0.016 is what, sir? What, sir? 0.062. Or gamma CT is what? Log gamma CT or gamma CT is what? You will get this gamma CT as 1.154. This is substitute here. Then you will get. You have to find out activity of cadmium. Activity of cadmium. So activity of cadmium, as I have already written, is gamma CT. XCT once more you write is 1.154 and XCT is how much? XCT is 4.5. You have this 0.77. 0.577 is the answer. So with this we have completed problem 4. Problem 4. So what it is? Solution. This was actually problem what it was? I am very sorry. Problem 5. This was problem 5. This is problem 5. Still I have this solution problem 5. Okay. So remove this. Problem 6. Next problem 6. Problem 6. Okay. Problem 6. What is the problem 6? At 473 degrees centigrade, the latent system exhibits regular solution behavior. Regular solution behavior with the activity coefficient with the activity coefficient with the activity coefficient of lead being given by log gamma B is minus 0.32 1 minus x lead whole square. This is given. Find activity of tin. Find activity of tin in the XPB is 0.6 alloy at 746 Kelvin and 1000 Kelvin. Again reference DR Gaskell, second edition, page 376. Let us take the solution. So remove this. Solution 6. Now I tell you something here. This is a regular solution behavior. What it says, see, log gamma B is minus 0.321 minus XPB square. given. This is regular solution behavior, right? Regular solution behavior. Regular solution behavior. Not modified regular solution, pure regular solution. Remember what we started? Ln, we started in the class. Ln gamma A is alpha xb square. Is it correct? Here A is late, B is what? Tin. Xb means 1 minus x late is x tin square xb square. Tin is B. And alpha is then what? Oh, this is minus 0.2. Very sorry. Minus 0.32, not plus. So alpha will be minus 0.32. But there is a little small change, small correction or modification. It is ln, that is log. So if you write log gamma A, what is this? It will be what? 2 alpha by 2.303 xb square. So what is this? This point minus 0.32 is what? Alpha by 2.303 is minus 0.32. What is alpha? Is minus 0.32 into 2.303. So don't worry about this point. It's just this discussion is not at all important. You can very easily find out. Okay, the log ln you can use either, but careful about the 2.303 factor. Okay, so don't worry. Given this, recall when ln gamma is alpha x square. When this, what is the ln gamma b? Can you remember? Regular solution. Ln gamma A alpha x square, what is that? Recall? Is similar. Ln gamma B is alpha similar. So you can write yourself, since regular solution behavior, you can write log, tell me what you write? Log gamma n. Here, same. Minus 0.32, 1 minus x late is here 1 minus x tin square. What is that? Minus 0.32. You can write given in terms of a late tin. Okay. Is right this x is right. It's x late. Why 1 minus x tin? X late. So makes sense. Ln gamma b is alpha x square. Ln gamma a alpha xb square. It's okay. So this is very easy. So now you find out what you find out? The activity. So first find the gamma. Which temperature it is 473 degrees centigrade. So log gamma Sn, what temperature? This data is for what temperature? What temperature? Tell me what temperature? 473 plus 273. How much? 746 K. This data is minus 0.32. First you consider XPB is 0.6 L, 0.6 square. 0.6 square. How much it is? Let me check the calculations. I have to take help. Minus 0.2 minus 0.6 is minus 0.1152. Or gamma tin 746 K. How much it is? Gamma tin is 0.767. You just set this. Gamma tin 1 temperature. So you complete this. Find the activity tin at the complete this temperature. Then they will take up this temperature. Answer for this temperature, then for this temperature later on. For this temperature, what is the activity T? What? Tell me. Gamma T times XSN. What is the gamma T? 0.767. What is the X T? X T, what is the composition? Give me. X late is 0.6. Means 1 minus 0.6 is 0.4. 0.6, 0.4. So it is 0.76 times 0.4. 0.31 activity or activity Tn is answer. First part activity 746 over 1000 Kelvin. What you will do? This relation is effective for 473 degree centigrade means 746 K centigrade. This is K. So what we will do for this temperature to find activity? You need to find gamma T for this temperature. Gamma T for this temperature. Then the activity is gamma T times the mole fraction. Mole fraction the same. For T is 0.4. So next to find gamma T what temperature? 1000 Kelvin. How will you get this? We know if we know gamma T for one temperature, do you know the gamma T for the other temperature? Regular solution be there? Yes, there is a rule for regular solution. T log gamma is constant. T log gamma is constant or T ln gamma is constant. Whatever. So since here log we are using, we may use log or ln at 1000 Kelvin. Use regular solution principle. You go back and see there T log gamma is constant. T log or ln whatever you call it, gamma T is constant. Or what you write this? Or log gamma T what temperature? 1000 Kelvin by log gamma T 746 Kelvin is nothing but cross 746 by 1000. This is known. Log gamma SN is how much? Minus log gamma SN. This is how much? 746 minus 0.1152. Or you get log gamma T 1000 Kelvin is from this is if we use this log gamma T 1000 minus 0.0859 minus 0.0859. Okay, or gamma T 1000 Kelvin is how much? It is 0.82. So again box this gamma T. So you get again take up this step activity SN active, hence activity SN is gamma SN times X SN is 0.82 at 1000 K. 0.82 times X SN is how much already? 0.4. 0.4 is 0.328. I made a mistake here, 0.767. I have not got this. It's okay, it's okay. Okay. Last one answer is why this is okay. This is one answer. Answer is second answer. This is the answer. This is for 1000 Kelvin. This is for 7. This is for 740. This answer is for 746 Kelvin, and this answer is for 1000. Thank you. With this, we have solved 6 problems. Now we'll take up the 7th one. 7th one. 7th one. Okay. I let me remove this. Problem 7. Last problem. This is the last problem. Problem 7. Actually, let me remove this. Problem 7. The activities of nickel in liquid iron nickel alloys at 1600 degrees centigrade have been determined as X nickel activity nickel 1 1. As everyone knows this, it is easy. We know already 0.9, 0.89, 0.8, 0.766, 0.7, 0.62, 0.6, 0.485, 0.5, 0.374, 0.4, 0.283, 0.3, 0.21, 0.2, 0.14, 0.1, 0.067. And when it is 0, activity is 0, 0, 0. It is not giving. Okay. So we have what you have to do? Find activity of iron in the XFE is 0.6 alloy at 1600 degrees centigrade. Means it is 1873 Kelvin. This is your question. Reference D.R. Gaskell. Page, second edition, page 376. How will you solve this? Can you remember how will you solve this? Yes, this will be solved by Gibbs-Duhem integration. Gibbs-Duhem integration in a graphical manner. So solution outline. I will not solve this here. Outline. Try yourself. Just I get you started. I get you started here like this. What is the pertinent one you consider this? Get you started here. Use gives Duhem equation. Which equation? What is this? That is XA d log activity of A, or A activity XA is X iron here, iron activity of iron plus X nickel X iron d log activity of iron plus X nickel d log activity of nickel is 0. Or you can call this, or you can use log or ln, whatever, log or ln. You can use log or ln, log or n. If you write ln, d ln x. Achha, I am writing it. Or just quickly, you can write any same d log d ln x nickel d ln a ni. Log may be convenient, more convenient. Okay, this will give you what? Remember, you have to find this one. You have to find. So take the left hand side, or d log Fe is what? Tell me. Minus x nickel by x Fe d log activity nickel. Activity nickel are given, so this should be plotted. Okay, so you have to plot this. You have to plot this. Then integration between what and what? X Fe is what? 0.6, and this is XP, for which you know the activity. Convenient reference. What is the activity when XP is 1? So you know integration D means log 1 is 0. So easy. This you know. So this solve graphically using the data in the tabular data, using the data in the table. Data in the table as discussed in the class. Discussed in the class. Try yourself. Just what you will do here, you plot here, see here, x ni by x Fe, and here you take this d of minus log n. You may have a minus d minus, absorb this minus. Okay. If you get this will be a, this will pass this type of curve. Do yourself. Do yourself. Okay. So this is up to you. And answer I give you. Answer is activity of Fe 0.55. Thank you very much. At least we have completed satisfactorily assignment number 9, the problem based on solution thermodynamics. We will continue with solution thermodynamics but with a different topic. So can I remove this? We will continue. So assignment number 9 over, all over. New topic. Very challenging topic. Very challenging topic is alternative standard states. Which are they? Henryan, 1 mole fraction, standard state, and another is Henryan, both on based on Henry's law. Henryan, 1 weight percent. Oh, 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 sorry. 1 weight percent standard state. I have to draw a diagram for this purpose. Okay.